2025 didn't go as planned.
535 marks.
बस थोड़े से मार्क्स से रह गई। बायोलॉजी ठीक था, केमिस्ट्री भी, पर फिजिक्स वो फिसल गया। इस बार पढ़ाई नहीं, तैयारी करो, वो भी स्मार्ट तरीके से, क्योंकि इन्फिनिटी लर्न लाए हैं अट्रेया, इंडियाज मोस्ट पावरफुल नीट रिपीटर्स प्रोग्राम विद P²CB, जिससे फिजिक्स पे होगा डबल फोकस।
Don't just make it your last try, make it your best one yet. Join Infinity Learn today.
Hello my dear students, welcome to one more amazing session from Infinity Land. This is Suresh, Faculty of Chemistry. How are you all? Please confirm, can you all able to see me, hear me? So a couple of minutes late, I apologize. How are you all doing? And आज हम चर्चा करने वाले हैं निर्माण सीरीज में beginning of quantum is. How the title is? Really outstanding title, my dear students. So the quantum mechanical model of atom is different. Here quantum mechanical theory of light is different. So why we need to learn nature of light? As we don't see the atom by using naked eye, we can't see the atom even if you use a sophisticated equipment. Rather you can see the image of the atom. To see the image of the atom, that is nothing but the spectrum. It requires a light. So light is a small thing which can go into the atom and can see what is there. So it is going to be given its properties. If you know the nature of light, you can understand what light wanted to say. So to talk about the nature of light, we have various theories. We have wave theory, we have particle theory, that is your quantum theory of light. आज हम चर्चा करने वाला है. आज हमारा एजेंडा में nature of light, उसमें wave theory and we have Planck quantum theory and Einstein photoelectric effect. These are the major topics that we are going to discuss in today's class. And all the best and stay tuned, and we are going to do the best for it. And before going for this little formality for us, so it is about launch of Atreya program. So what is this Atreya program wanted to say? Just only 2 minutes, stay tuned and so that we can start the class, right? And this Atreya program, India's the best powerful NEET repeaters program. And this Atreya program will change you from a state of I didn't do it to I will do it and I will do. Yes, exactly. By using revolutionizing program P²CB. What is this P²CB? So it's a generous problem for the entire student community preparing for your NEET examination. It is simply physics is the hardest and toughest subject and evident, and it is proved in 2025. Everybody got slapped with physics paper. But Infinity Learn is going to take care of you, and Sri Chaitanya Academy by Infinity Learn, you can see physics is on us. We want to come up with some solution for this universal problem. So that is P²CB. Atreya, India's most powerful program for NEET repeaters, bachcho. Revolutionizing NEET preparation for P²CB. So what P²CB says? Double focus on physics with chemistry and biology. Yes. So why you need to double? Systematically you have to double it. Let us talk about what is this Atreya program structure, and batch commenced already May 23, and you will be having remedial classes for that also, and days of the Monday to Saturday the classes will be there, and Sunday ko chutti hai, and every day the class duration is 90 minutes, 1 hour 30 minutes pakka by the expert faculty, and 3 classes per day. उसमें 2 concept classes होगा, एक practice session होगा, and classes per week, and there are 18 classes per week, double practice class for your physics. This is important, double class for physics. And also you will be having interactive classes by expert faculty, 465 interactive classes by expert faculty, 240 DPPs, and dedicated practice classes 120 hours more. And also after class revision notes will be there in the PDF form, and you need not have to prepare the notes and taking a huge amount of time, not like that. And this is the most sound. 20 to 25 students will be there in your practice session, so that you will be having a very good interaction between your faculty and you. A rapport will be built and customized doubt clarification is possible. We are not going to put you in these hundreds of students and thousands of students for the cheaper prices. Okay, so this is a very, very important point, my dear students. Also, coverage of the syllabus 11th and 12th will be there, and you can do the best. Okay, dear students, here I wanted to say, once you already done your NEET examination, you can check your rank and college predictor. Link is there in the description box. You can just click it and you can do the best. And promotion is over and formality is over, and let us start the nature of light. Our nature of light, and the nature of light, you have two behaviors. One is nature of light, and this nature of light, two types are there. Wave theory is there and particle theory is there. So according to wave theory, let us discuss about the wave. This is the animation given by our content team, and the people are working based on doing these animations, and it is a super awesome thing. Actually, this is a two-dimensional picture. It is given in the textbook. And if you see the two-dimensional picture, you don't understand. I am going to tell you what it is. And light is a form of energy, and it propagates in the form of wave. And this wave is of two things, and this is the axis of propagation. And there are two waves which are perpendicular to each other. One is electric field strength is increasing and decreasing. Blue color one is electric wave, and red color is a magnetic wave. And the propagation direction and the electric field strength and the magnetic field strength, these three are perpendicular to each other. Are you getting or not? Clear? And this is, one is increasing and decreasing. As electric field is increasing and decreasing, immediately that energy force is carried out by the magnetic field. So once the electric field is increasing and decreasing, it is going to taken care by this magnetic field. So magnetic field increases and decreases immediately, simultaneously, alternatively. Electric field strength and magnetic field strength perpendicularly increases and decreases. Therefore, it do not require any medium to propagate. That is the why in the vacuum also light is going to be propagated. Hope you understand. This is the wave actually behavior. So let us talk about the wave nature. Let us talk about the wave nature. And this is your properties of electromagnetic wave. The electric field and the magnetic field components oscillate perpendicular to each other, as well as the perpendicular to the direction of propagation of the wave. And that is given diagrammatically, this one. Got it? Yes, that is given diagrammatically like this. You like this? Everybody? My dear children, you can interact with us and you can ask any kind of doubts during a session. This is not actually a recording session. This is a live interactive session, so that you can have a very good rapport with the faculty. And this NEET Nirman program is going to cover total 11th standard and 12th standard program, and all the subjects, and every day you are going to have the sessions. My dear students, you can take a pen and paper, write the important points as you wish, and you can get very good important points based on this. Okay, my dear children, here let us talk about this electromagnetic wave behavior. And electromagnetic wave do not require a medium and can travel in the vacuum, because one field is increasing and decreasing, so that is going to be the driving force. And also electromagnetic wave propagate at a constant speed in the vacuum, which is equal to approximately 3 into 10 raised 8 meters per second, denoted by C. And if you see the wave, it is coming like this, and every point. Today we are going to discuss about wave theory, particle theory, and the photoelectric effect. So this photoelectric effect can give you insight for the physics as well. So take care of this. And the properties of electromagnetic wave, these are the types of radiations which differ from one another in the wavelength. They have the constant value of the light, but the wavelength and frequency, they may vary, and which is called as electromagnetic spectrum. So let us talk about, to understand electromagnetic waves, let us understand wavelength, frequency, velocity, wave number, and amplitude. And what are the parameters of the wave? Wavelength, frequency, velocity, wave number, and amplitude. These are the 5 important variables that you can see based on the waves. And you can see this is your wave. The wave is going to up, down, up, down, up, down, like this. And this is the propagation of the direction. This up one is called crest and down one is called trough. School mein padhai kiya aap log? Okay, so you can see the wave, and this is the point of crest and this is the point of crest, and the distance between two successive points, it could be between two crests or two troughs in the same phase, and it is going to be wavelength, and this wavelength is indicated with a symbol called lambda. And lambda is the distance between two successive crests or two successive troughs or two any successive points which is in the same phase. And you can see the height of the crest or depth of the trough is called as amplitude. Actually, the intensity of the light increases, amplitude increases, mind it. Intensity, what is the meaning of intensity? Brightness of the light. Are you getting or not? As intensity increases, amplitude increases, and this is your wavelength and amplitude, and LEM wave characteristic, electromagnetic wave characteristics. Okay, let us see the some more details about this. You can see velocity, it is said to be c or v. Its velocity value is going to be distance traveled by the wave in 1 second. You know the value, it is going to be 3 into 10 raised 8 meters per second, and SI unit is going to be meters per second, my dear children. And always prepare NEET examination in such a way that while you are learning, learn in a granular manner. So whenever a question with a depth or question is coming by twist and turn, agar question guma ke aage, to granular level subject is going to give you support. That's the reason why you all fix to the concept level only. And also it is related to the frequency wavelength as. What is the meaning of frequency? Frequency is nothing but the number of waves that pass through a point in a second is called as frequency. It is going to be hertz or second inverse. And the frequency is given as nu, and the wavelength is given as lambda, and the c is going to be nu lambda. Nu is going to be frequency here, and the lambda is going to be wavelength here. Now nu is equal to c by lambda. You can see frequency, it is nothing but the number of waves that pass a given point in 1 second, and it is going to be SI units hertz, Hz, or second inverse. And also frequency is equal to time inverse, so it is going to be second inverse. Time period, you can say. And wave number, actually the wave number is introduced. When it comes to the wavelength, its value is as small as in angstrom units, picometers, nanometers, while the wavelength can be in centimeters and meters also. That's the reason why we use wave number. Wave number is the number of waves in a wave, a particular length is number of waves in a given length. So it is a inverse of the wave length. The number of waves per unit length is called as a wave number. It is pronounced as a nu bar, and a nu bar is said to be inverse reciprocal of wavelength. It is the reciprocal of wavelength. Okay, and nu bar is equal to 1 by lambda. That's the reason why nu is equal to c by lambda. Nu is equal to c by lambda. So I can say c into 1 by lambda. So 1 by lambda is equal to nu bar. That's the reason why nu is equal to c nu bar. You understand this? Clear? So nu is equal to c by lambda. Nu is equal to c into 1 by lambda. So we know that nu bar is equal to 1 by lambda. So I just want to write as a nu bar. Nu is equal to c nu bar. Okay, that's very important. That's very important. You all just make a note of the cheat sheet you have to maintain, and among the cheat sheet you can write these formulas, and the arrangement of the what is the electromagnetic spectrum. So the arrangement of all the wavelengths in a given source of light is called as a wave spectrum or electromagnetic spectrum. The frequency you can take the wavelength, and it is pictorially arranged, and it is called as electromagnetic spectrum. And this electromagnetic spectrum, you can say, when you take a light and pass through a prism, you are going to see wave GR that is visible to you: violet, indigo, blue, green, yellow, orange, red, wave GR. That is only the bandwidth. This is the total spectrum. In the total spectrum, and this is the smallest range you are going to see by your human naked eye. And beyond that, ultraviolet rays, X-rays, gamma rays are there. And after this, infrared, microwave and radio waves are there. And when you see, energy for these infrared rays is less, and energy for ultraviolet rays are more. So energy is inversely proportional to wavelength. So we can write this as hc by lambda. So energy is increased, wavelength is decreased. Okay, energy is equal to h nu. So I mean to say energy is increased, frequency is also increased. That's the reason why you can see the wavelength. That's very, very important. Ultraviolet and X-rays and gamma rays, above that cosmic rays. You understand this? Cosmic rays are, gamma rays and cosmic rays are so dangerous. Yes. So when the gamma rays, you see, ultraviolet rays are used for the sterilization purpose, and ultraviolet rays are used for detection purpose, and X-rays, you know, it is used in, X-rays are used in medical purpose for scanning, and also X-rays are used for security purpose to scan what is there in your luggage and the suitcases and all, and gamma rays are used in radiation therapy and various purposes, and these are all different things. And talking about infrared radius and microwaves and radio waves, let's see here. Infrared radiation is used in creating heat and for the medical purposes, and also microwaves are used for various waves, like you can say semi microwaves are used in cooking. Okay, hi Katri, what is this? and the radio waves are used in telecasting, and it is for the radio waves. It can be used for AM waves, and you can use for FM waves, you can use for telecommunication systems. Okay, dear children, focus on the things, and here only VGR is usable and it is visible for us. Beyond that, ultraviolet radiation, and after this infrared radiation. This infrared radiation has wavelength is going to be increased. So wavelength is going to be increased, and the wavelength is going to be decreased over here. As the wavelength is decreased, the energy is the highest here, so that energy is decreased, energy is decreased, energy is decreased. The least energy is seen here. You understand? So energy is decreased here, the least energy, and this wavelength is increased here, and the wavelength and the energy are going to be inversely related. Understand? And moving ahead, so this is the wavelength of various things heating upon an iron rod. Let us talk about this the nature of light. So the nature of light, wave nature is well accepted. So it can explain the diffraction process, it can explain interference process, and it can explain the propagation process, while it cannot explain the photoelectric effect, it cannot explain the black body behavior, it cannot explain the Compton effect. So these are all explained by using the black body radiation. When you talk about the heating up of iron rod, when you heat the iron rod, initially it is going to be red for 5 minutes or 10 minutes. If you heat it for 15 minutes, if you heat it for 30 minutes, if you heat it for more than that time, and as the temperature is increased, it is going to be more and more energetic in its spectrum. So the behavior of the heating body is explained on this basis. So what is that? You can explain based on the black body radiation. So black body, ये black body क्या है? कलर का हिसाब से नाम नहीं दिया. Okay, so a black body is a substance which can absorb all radiations falling upon it. Children, a black body is a substance which can absorb all radiation falling upon it, and absorb, and it is going to re-emit the same radiation, maybe with the same frequency or the different frequency. And this kind of hypothetical substances are said to be a black body. We are not going to study the black body because the perfect black body we don't have on the earth. Okay, so sun is considered to be a perfect black body, and also we can have hot metallic objects behave like a black body. So why this black body we have to study? So there are certain behavior of the light cannot be explained on the basis of the wave theory. So that particle theory is given by the study of black body by Max Planck, and it is given as a, what is a black body? A black body is a hypothetical black body. It is an idealized physical body that absorbs all incident radiations falling upon it and re-emit the same. करण सर नीट के आंसर की और OMF कब आएगी प्लीज? एंड अगले हफ्ते को आएगा बेटा. करण अगले हफ्ते को आएगा. You want to see your OMR? Definitely it will be, right? So expect it to get in the next week. So once you got this, and I am going to do some kind of live videos and short videos based on that. Stay tuned. Okay, and you can say why the name black body? By the name of the color? By the name of the color? No, it is all the why the name black body. Visually black body versus radiatively black body. I am wearing a red shirt. Okay, it is visually red, But when it comes to the radiations, violet, indigo, blue, green, yellow, orange, red, it is falling on it. So it absorbs blue wavelength. So all the wavelengths are coming and blue is absorbed, and so that red is reflected. So you can see this color is red. That is called radiation. There is, that's good, thank you, there is Kumar. Thanks for your compliment. And सर धर भी रह रहा है लास्ट ईयर का तरह न जो है अच्छे नंबर होने से नो 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 करण no fear, I am Infinity Learn is going to take care. If you do it, well and good and congratulations, and if you don't do it, we'll make it for the next dropper ke liye, I will do it. Okay, so think positive and enjoy your life. Okay, so if you keep finding something, it is I am feeling fear na, it is going to be really painful. Are you getting or not? Clear? That's good. So let us focus here. Visually black body and radiatively black body. And this is a radiatively black body is the term we are going to use it. So a radiatively black body, I just want to talk about the behavior of black body. So Max Planck studied about the black body radiations. The radiation given by the black body is called black body radiations. How he got the black body? He made it, and a zirconium oxide is made it into a paste and made a ball, and it has a pinhole, and it heated to 1500 to 2000 Kelvin. And Karan, okay, God bless you, my greetings and my blessings. Okay, beta? Take care, don't worry. So what I mean to say, the black body is going to radiate, and the radiation of the black body is studied by Max Planck like this. And actually what this black body, this is a black body and it is radiating, and if the radiation, this is a hot black body, it is heated, so that hot metallic object gives the radiation. If the radiation is given continuously like this, it should appear, a graph appear like this. Okay, the intensity and the wavelength is studied here. It should appear like this. It should appear like this. But it is not appearing like this. It is not appearing like this. It is appearing like this. So what is exactly? Okay, thank you, Karan. Thank you. It is observing as the temperature is increasing. Okay, intensity is increased. So 3000 Kelvin intensity itna tha, 4000 Kelvin intensity itna tha, and 5000 Kelvin intensity itna tha. Okay, that is the first important point. And as the temperature increases, okay, the peak of the curve, low temperature mein red tarik hai, peak is at red, and 4000 it is at yellow, and at 5000 Kelvin it is at blue or green, and 6000 Kelvin if you see, it is going to be like this. The peak is going to be at violet. Okay, so wavelength is decreasing as temperature increases, wavelength is decreasing. So as temperature increasing, the wavelength is decreasing, shifting to the lower side. So based on that, actually if the light is continuously, it should come like this, but it is going and coming down. That's the reason why we can say that light is not coming like this, rather light is coming like this, discontinuous. So that is the interpretation it is given. So it inversely proportional to lambda right here. So he wanted to say particle nature of radiation is given by Max Planck, energy of radiation is quantized. He wanted to say this is a hot body. So he wanted to say the hot body is going to emit, absorb or emit the radiation, in the form of a small energy packet, and this packet is called packet of energy, called quantum of energy, and this is called quanta. This is said to be quanta, and each quanta has certain amount of energy associated with it, and that is given. Planck's quantum theory could explain the variation of intensity with wavelength. variation of intensity with wavelength. Understand? Yeah, moving ahead, according to Planck quantum theory, hot metallic body can absorb or emit radiation not continuously, Varsha, high, but discontinuously in the form of energy packets called quantum, and each quanta has certain amount of energy associated with it. Okay, and let us discuss about this quanta. This quanta, उसमें क्या? Just energy, packet of energy. Max Planck wanted to say it. So that energy is directly proportional to the frequency of radiation. That energy is directly proportional to the frequency of radiation. So that is called as h nu. Okay, that is called as h nu. Varsha, hope you understand. So E is equal to energy of each quanta. It is also called as photon. Max Planck given his theory, that is Max Planck quantum theory, so he called this as a quantum. Later on the same is proved by Einstein, that is called Einstein quantum theory, both are same. Max Planck studied on black body and Einstein studied on photoelectric effect. So when Max Planck said it is quanta, Einstein said it is a photon. So both are same. Varsha, E is equal to energy of packet, energy of quanta, and nu is equal to frequency of the radiation. Frequency of the radiation. Okay? And h is equal to Planck's constant. Planck's constant. Could you say what is the value of Planck's constant, Varsha? 6.626 into 10 raised minus 34 joule second, or 6.626 into 10 raised minus 27 erg second. Both are same. It is an SI unit, it is in a CGS unit. You know, it is also written as E is equal to hc by lambda. E is equal to hc by lambda. You can say c is equal to light velocity, and it is going to be 3 into 10 raised 8 meters per second, and lambda is equal to wavelength. Okay, you know the wavelength 1 angstrom unit is equal to 10 power minus 18 centimeters, right? Exactly, Varshasri. So based on this, I would say E1 by E2 is equal to lambda and energy are inversely related. So lambda 2 by lambda 1. Okay. And he wanted to say this, the entire particle nature of the radiation is quantized. So the quantity of this radiation is fixed. Okay. And energy packet is fixed. Do you understand? Clear? And here quantum theory of light, according to Planck, the smallest quantity of energy that can be emitted or absorbed in the form of electromagnetic radiation is called quantum of radiation. And this quantum of radiation was called photons, or the quanta packet bundle energy. Okay, Varsha, and also see here the energy of quantum relationship with this frequency, and it is given E is equal to, E is directly proportional to the frequency of radiation, and E is equal to h nu or hc by lambda, that we already discussed. H is equal to Planck's constant, its value is, as Varsha said, 6.626 into 10 power minus 34 joule second, SI units. Okay, E total is equal to n h nu. So I wanted to say that was the energy of the one photon. This is the energy of 1 photon, and this is the energy of n number of photons. This is the energy of n number of photons. Understand? And here calculate the energy of 1 mole of photons in the radiation whose frequency is 5 into 10 power 14 hertz. So, if that kind of question comes now, how do we calculate? We know that children, E is equal to h nu, or E is equal to n h nu, right? So, 1 mole of photon, so that is n is equal to, here 1 mole means 6 into 10 raised 23. Okay. So, 6 into 10 raised 23, h value is 6.626 into 10 raised minus 34, okay, into nu value is going to be 5 into 10 raised 14. Okay. So, that you are going to get the answer joule per mole. Clear? You understand? And I have a simple trick. And also 199.51 kilojoules. Varsha, you can say 200 kilojoules, I can say approximation is required if you want to say that. And I have a simple trick. I have, dear children, E is equal to hc by lambda, and 6.626 into 10 raised minus 34, and 3 into 10 raised 8 upon lambda expressed in meters. And when you simplify this, you are going to get energy is equal to 2 into 10 raised minus 25 upon lambda is given in meters. So, that you are going to get in joules. You are going to get in joules. It's a very important simple conversion, right? Varsha, hope you understand. Clear? And also you can say E is equal to 12400 upon lambda. When you take this lambda in angstrom units, you are going to get in electron volt. Electron volt is a unit for energy. So, you know 1 electron volt is going to be 1.6 into 10 raised minus 19 joules. Got it? Clear? And these are the simple tricks that you can directly use for your NEET examination. समझ में आ रहा है क्या Varshashri? Are you getting or not? And once you follow the class directly, you are going to get these much simple tricks. These much simple tricks. है ना? अगर कुछ डाउट होने तो पूछना बेटा. या अगर कुछ डाउट है ना तो पूछना जल्दी. No doubts. Fantastic. Fantastic. So, let us see one more question. A 100-watt bulb emits a monochromatic light of wavelength 400 nanometers. Calculate the number of photons emitted per second by the bulb. It is a popular question. Okay, it's a very popular question. And the wavelength is given as 400 nanometers. 400 nanometers means 1 nanometer is equal 10 power minus 9 meters. Therefore, lambda is equal to 400 into 10 to the power of minus 9 meters. Got it? and calculate the number of photons. You are asked to calculate what is the n value. You know E is equal to n hc by lambda. Okay, you see, you are asked to calculate the n. Okay, so 1 watt is equal to 1 joule per second. The question is asked for the second only. So, a 100-watt bulb is going to give you 100 watt is going to be 100 joules per second. So, let us equate with 100 joules per second. Okay, n you have to calculate hc by lambda 6.626 into 10 power minus 34 into 3 into 10 raise 8 upon lambda. Okay, so I just want to give you the lambda value here. The lambda value here, that is going to be 409. Okay, it is going to be 400 into 10 power minus 9. I told you this is your trick. You can equate it with 100 is equal to n into 2 into 10 raised 25 upon 400 into 10 raised minus 19. Now, so solve for n, you are going to get the answer. Got it? Clear? Math is my life, chemistry is my life. You know, math is your life and chemistry is my life. So, Varsha, what is your answer here? Anisha, you are there in the class today? Anisha, are you there in the class today? Well. Yeah, it is going to be minus 25. Ha, minus 25. Bhul gaya main. Okay. So, what could be the answer here? Nearly. Now, photoelectric effect. Can we start the photoelectric effect? So, the photoelectric effect is explained based on this quantum nature of light. So, 2 into 10 power 24 approximately. Yeah, you can make it 2 into 10 power 24 approximately. Not a problem. Now, photoelectric effect. So, the photoelectric effect is going to be the most important, and Einstein got the Nobel Prize based on this photoelectric effect only. So, this is your photoelectric effect. So, when a light of a suitable energy or a frequency or wavelength is allowed to fall on a metallic plate, ejection of electrons takes place. Dear children, this is your metal. When this light is allowed to fall on it, so that electrons present in the metal is going to be taken out. You can see when this light is allowed to fall, you are going to see the ejection of electrons. Are you getting or not, Varsha? Okay, Varsha, you can see, all the students you can see, when this light is allowed to fall on the metal plate, so the electrons present on the metal plate is going to fall ejected. So, it is going to be, when the electrons are reaching from this place to this place, you are going to connect with the circuit, so that you are going to see there is a deflection in this galvanometer. Understand? Clear? And this phenomena is known as photoelectric effect. This phenomena is known as photoelectric effect. Are you getting or not? So, exactly what happens? So, Einstein wanted to say this is a nucleus and the electron is revolving around the nucleus. When the electron is revolving around the nucleus, so there is an attraction force between the electron and the nucleus. So, there is an attraction force. Understand? And when a light of suitable frequency or energy is allowed to fall, this is your light. So, this is your light. Okay. So, this light has energy packets. Now, when this light has energy packets, this energy packet is going to be absorbed by the electron. The moment it is absorbed, okay, so this electron is going to absorb the photon, gets disappeared. When the photon is getting disappeared, it is going to break the nuclear force. Therefore, the electron is jumped out of this. So, electron is moving with a lot of kinetic energy. This is the explanation is given by Einstein. So, that energy of the incident light is used for two things. So, that is given W naught plus Ke. Okay. So, this is the energy of a photon, energy of incident light, and this is a work function. This is a work function, this is the kinetic energy. Kinetic energy of the photoelectron, and this is what is called as photoelectric effect equation. Are you getting or not? Clear? Varshashri, any doubt? Any doubt? So we are going to see the detailed version of each and every point, and let us see the application of this photoelectric effect. My dear children, yes, that's good, fine, wonderful. That's good, fine, wonderful. Let's see here. Only for certain radiations the photoelectric effect works, not for everything. Okay, not for everything. I mean to say, if potassium metal is there, if the red light is falling on the potassium metal, okay, if this is the potassium metal, okay, and if red light is falling on it, okay, so no effect. If the potassium metal is there, you can see violet light is passed on it, then you can see the electron is emitted from this. Yes, effect is there. When you talk about cesium metal, when red light is falling on it, yes, photoelectric effect takes place. Photoelectric effect takes place. The cesium metal is taken. Okay, cesium metal is taken. Okay, when you can see the violet light is passed on it, falling on it, yes, you can see the ejection of electron even. So, a metal is experimentally observed the photoelectric effect with a certain characteristic wavelength, Varsha, and that is seen here. One rule to remember, one photon can eject one photoelectron. That is one photon, one photoelectron and one interaction. So, as the number of photons increases, how do you increase the number of photons? By increasing the number of photons is increased by intensity. As the intensity is increased, we can say photoelectric intensity is increased, photoelectric number electron increases, so it is going to increase the photoelectric current. But the voltage is different, and if the energy of the incident light increases and the photoelectric voltage increases, kinetic energy of these photoelectrons increases. So, you can see, while you can see here, red light has less energy, violet light has more energy. I just want to see, here red light is used in this experiment. In this experiment, you can say yellow light is used. In this experiment, you can see violet light is used. What do you observe based on this? If red light is used, red light has very less energy, so less energy is there, so that the electrons which are coming here with less energy, less kinetic energy. Okay, yeah, wavelength is inversely proportional to energy, Varsha, exactly what he said is correct. And when you use yellow light has little more energy, and little more energy is going to have more kinetic energy as compared to this, K is low here, K is more here, right? Now, when you use violet light, you can see the kinetic energy of these electrons so fast. You like this? You like this animation? Okay, our animation, this PPT is prepared by our animation team. Okay, and yeah, thanks for the team, and they did it well. They did it well. ऋतिक राज हिंदी मीडियम में भी पढ़ाई कर सकते हैं डिमांड के हिसाब से. ओके, आप अगर कम एनर्जी वाला का लाइट इस्तेमाल किया है ना, जो रेड लाइट है, एनर्जी इन्वर्सली प्रोपोर्शनल टू द वेवलेंथ है ना, सो ज़्यादा वेवलेंथ होगा तो एनर्जी कम होगा. ओके, इसका जो काइनेटिक एनर्जी, इलेक्ट्रॉन को जो काइनेटिक एनर्जी कम से कम होगा. एंड जब आप वायलेट लाइट इस्तेमाल किए ना, इसका ज़्यादा एनर्जी होगा. ओके, कम फ्रीक्वेंसी या कम वेवलेंथ होगा. सो दैट इसका फोटो इलेक्ट्रॉन्स को भी ज़्यादा काइनेटिक एनर्जी होता है. वर्षश्री, फाइन. एंड यू कैन सी द बेस्ड ऑन दैट वी कैन से थ्रेशोल्ड फ्रीक्वेंसी. Threshold frequency is the minimum frequency that is attributed to the photoelectric effect. Okay, we can say E is equal to W naught plus KE. So W naught is equal to work function. W naught is equal to work function. So the minimum energy that required to cause a photoelectric effect. है ना? That energy has some frequency, that is what is called as W naught is equal to H nu naught. Okay, nu naught is equal to threshold frequency. In the physics they said to be critical frequency भी बोल सकता. And we can use the E is equal to H nu. ये nu क्या है? Incident light frequency. This is your incident light frequency. Incident light frequency. इससे E is equal to H nu. W naught is equal to H nu naught, and Ke is equal to half mv square, right? And we are going to discuss about that in the detailed version. Experimentally graphs भी आपका तैयार है. Okay बेटा, so Ke is equal to H nu minus H nu naught, and H common निकाल दो, nu minus nu naught. Yes, this gives you a lot. And this is going to be E is equal to K is equal to half H nu. That's the reason why I just want to say kinetic energy, you can say kinetic energy versus frequency, you are going to get a straight line and intercept on giving rise to the frequency, and this is going to be threshold frequency. Okay, as the frequency is increased, photoelectric effect do not takes place. Photoelectric effect चालू होता है ना, where kinetic energy is going to be zero, and as the kinetic energy frequency further increases, gives rise kinetic energy also increases. And this is a super awesome graph that I just want to say. Points to remember: when a photon of sufficient energy strikes an electron, and with no time gap, the electron grabs that photon, and it is going to break the nuclear forces and escape out of the atom, and this is what is called as the photoelectric effect. And threshold frequency already mentioned. The threshold wavelength and the frequency are inversely related, and the minimum wavelength that required to cause the photoelectric effect is called as a threshold wavelength. And plotting kinetic energy versus the frequency, that is a kinetic energy versus a frequency. And here, if there are two things here, Ke is equal to H of nu minus nu naught. Okay, if incident light frequency is less than critical frequency. Okay, no photoelectric effect takes place. No photoelectric effect takes place. Understand? So that is what is happening here. When the photoelectric effect takes place, if nu is equal to nu naught is equal to photoelectric effect takes place. If that is the case, kinetic energy is going to be zero. शुरू में kinetic energy is going to be zero. Here kinetic energy zero है ना. If nu further increases na, so if nu is greater than nu naught, so photoelectric effect takes place and Ke is greater than 0. That is what it is happening here. Got it? Clear? Varsha? Any doubt? Can we solve a couple of questions based on this? Fine? That's good. Wonderful. Now, let us see threshold frequency of a metal is nu naught is equal to 6 into 10 to the power of 15 hertz. Calculate the kinetic energy of electron emitted when radiation of frequency 1.0 into 10 to the power of 15 second inverse heats the metal. We know the kinetic energy is equal to h of nu minus nu naught. Okay? It is going to be 10 beta. It is going to be 10 beta. It is going to be 10, not 1.0. Okay? Now, if it is there, 6 point h value, we know that 6.626 into 10 power minus 34 of nu is equal to 10 into 10 to the power of 15 minus 6 into 10 to the power 15. And it is going to be 6.626 into 10 power minus 34 into 10 minus 6 is equal to 4 into 10 to the power 15. Okay, joules. So, what is the solution for this? What is the solution for this? Varsha Sri expecting answer from you. Expecting answer from you. When the question comes na, everybody should get the answer. I want to see what is the best you can give. Make it fast. बच्चों solve करके बता देना जल्दी. Yeah. Max, is that? Now, moving ahead, the radiation of frequency hits a metal, the electron is released to maximum kinetic energy, calculate the threshold frequency. Again here kinetic energy, the same formula h of nu minus nu naught. Okay, you can see the kinetic energy when the radiation of frequency is given, kinetic energy is going to be 1.988 into 10 raise minus 19 is equal to 6 into 10 raise minus 34. It is going to be when the heating 1.0 into 10 to the power 15, you have to calculate nu naught. Okay, this is your answer. Got it? Clear? Okay, now moving ahead, Hc by lambda in terms of electron volt. Now you can see 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joules. It is super important conversion while you are solving modern physics. Varsha, you're back here. That's good. Nice. Now talking about when electromagnetic radiation, okay. So acceleration, deacceleration of the charged particle. Now you can see here, when the particle is left between the two charged plates, it is getting accelerated. Okay, so the acceleration potential means you can say stopping potential. So you have to apply the external electric field. You can say this is your metal and here it is going to be collector. Okay, it is going to be a battery is given here. Okay, when you give the light, you are going to get the electron with certain kinetic energy, electron with certain kinetic energy. If you provide external EMF, some voltage, to stop this kinetic energy, they are going to be stopped. That is called stopping potential. That is given when the kinetic energy is going to be 0. So the potential applied to makes the kinetic energy of the photoelectron is going to be 0 is called as stopping potential. So I just want to say intensity also. Intensity means the brightness of the light. Brightness of the light, okay, and as the intensity of the radiation increases, in terms of wave theory, amplitude increases, in terms of quantum theory, number of photons increases. I just want to say number of photons increases. So intensity is nothing but increase in the number of photons. Increase in the number of photons, okay. And you can say when you can see this is your photoelectric photovoltaic meter. This photovoltaic meter, when the light intensity, when the light is falling on the metal, okay, the electrons are coming and hitting on the other side, that is called detector. It is going to increase the voltage. But here when the intensity is increased, what happens? It is going to change. You see here, my dear children, you can see here the intensity, you can see the brightness of the light. Low brightness, low number of photoelectrons are less. More brightness, number of photons are going to be more. You understand? Clear? And that is indicated by how current is affected by frequency of radiation. Yes, frequency of radiation increases, current has no effect. As the frequency of radiation increases, photoelectric current has no effect. Okay, intensity has effect. Okay, this is very important. And similarly, I want to say here kinetic energy and intensity. You can see, my dear children, kinetic energy, intensity. Again it is going to be a straight line path parallel to that. So intensity has no influence. If we talk about the kinetic energy and frequency, as the frequency increases, kinetic energy increases, and it is going to be a straight line and with a positive slope, and this point is said to be critical frequency, threshold frequency. Varsha, hope you understood. These graphs are very, very, very important. And also you can see how current is affected by frequency. Yes, so electron kinetic energy maximum, radiation of frequency is not at all affecting. When a stopping potential and accelerating potential, it is going to get a sigmoid curve on the photoelectric current. You are going to see this much more in the physics, less in the chemistry. This application is not related to chemistry. And you can see photoelectric current, accelerating potential, retarding potential. This retarding potential is the one which deaccelerates the kinetic energy. It is going to be the other side of the graph, and these graphs are going to be important even for your physics. Okay, Varsha. and you can see variation of photoelectric current with potential difference and the frequency of radiation. You can see here as the potential increases, he is going to change. Just a minute. And retarding potential is decreasing, and it is going to increase the photocurrent, okay, and it gives a lot of impacts over here, and it is experimentally verified values. You can see these pointers also, and mostly in the modern physics you are going to see this, and also as these pointers increased, various things are going to be seen. Variation of photoelectric current with potential difference in intensity of radiation also. You can see, dear children, as intensity increases, photoelectric current increases, and this is going to be stopping potential. From here only we have to see the sigmoid curve, right? And also you can see, and I want to give you the graphs over here. Energy of the incident light, is equal to W naught plus Ke, and Ke is equal to energy minus W naught. So as far as the chemistry part is concerned, we have a specific formulas. So the kinetic energy is equal to half mv square. Kinetic energy is equal to h nu minus h nu naught, dear. Okay, Varshasri, come on. Let us talk about the Ke is equal to h of nu minus nu naught. That's it. Okay. From here you can also say half mv square, mass into velocity square. M stands here the mass of the photoelectron, mass of the electron here, and v is the velocity of the photoelectron here, and is equal to hc by lambda minus hc by lambda naught. Okay. You can also say half mv square is equal to hc of 1 by lambda minus 1 by lambda naught. You can have various kinds of discussions over here, right? And where is the lambda is equal to incidental light wavelength, and the lambda naught is going to be critical wavelength or threshold wavelength. Okay. And we have a couple of graphs we need to learn, and let us talk about these graphs. And here you are going to see the kinetic energy and the frequency. You are going to see a straight line on intercepting of the frequency, and based on this you can say this is going to be critical frequency. And also if you want to increase the kinetic energy and intensity, you are going to get a straight line. Got it? You are going to get a straight line. On intensity is not. And also photoelectric current. You want to say current, and it is going to be frequency. So photoelectric current amperes is also almost 0 here. Karan sir, please ask बार में छोटे से बात करना. किसका जीवन से? Okay, leave it. So based on this graphs, you are going to get multiple option questions in the NEET examination. So this is end for today's class, my dear students. We are done for today. And Varshasri, and hope you understand, Ritik Raj and Karan, and don't worry, in the next week we are going to see with one more session based on the OMR sheet and the key and the score checkings and all. Dear children, today we talked about the nature of light. Jivansh, okay, Jivansh, God bless you beta. Jivansh, God bless you. And चिंता मत करो. ओके, आपका नेक्स्ट वीक में आपको OMR मिलेगा. ओके, एनीवेज मैं क्या बोलना चाहता हूँ, ये हमारा ये जो सेशन में नेचर ऑफ लाइट पढ़ा है. सो इन द नेचर ऑफ लाइट, वेव नेचर, इलेक्ट्रोमैग्नेटिक रेडिएशन and its behavior, and also we studied this Planck's quantum theory and black body radiation and the photoelectric effect, and variation of photoelectric effect, frequencies and intensities, kinetic, energetic, everything we have discussed. Okay, and I think you like this session, and please share with your friends and subscribe to NEET Infinity Learn NEET YouTube channel. Okay, thank you. We are done for the best. Okay, see you. God bless you, and we'll meet with more stuff in the next class. See you. Signing off, Suresh, Faculty of Chemistry from Infinity Learn from Sri Chaitanya Academy. Thank you. Thank you very much.